Space is often depicted as a freezing and hostile environment in science fiction movies. But how cold is it really? And does it make sense to talk about the temperature of space? You're watching Luminary Cosmos. In this video, we will explore the physics behind the universe's temperature, the hottest and coldest regions of space, and the implications of exposure to space for humans and other objects. So watch this video till the end and do not forget to subscribe. First of all, we need to understand what is temperature and how is it measured. Temperature is a measure of how fast the atoms and molecules in a substance are moving. The faster they move, the more energy they have, and the higher the temperature. Heat is the transfer of energy from one substance to another due to a difference in temperature. Nature tends to balance out the temperature of different substances, so that the heat flows from hotter to colder regions until they reach equilibrium. There are different ways to measure temperature, depending on the type of substance and the scale used. For example, we can use a thermometer to measure the temperature of a liquid or a gas by observing how it expands or contracts with the temperature changes. We can also use infrared sensors to measure the temperature of a solid object by detecting the amount of radiation it emits. Now coming to our main topic, how cold is space? Space is not a uniform substance, but rather a vast emptiness filled with various particles and radiation. Therefore, it does not have a single temperature, but rather a range of temperatures depending on the location and conditions. However, there is a minimum temperature that space can reach, which is determined by the cosmic microwave background radiation, CMBR. The CMBR is the leftover radiation from the Big Bang, the event that created the universe about 13.8 billion years ago. As the universe expanded and cooled, the radiation stretched and lost energy, becoming fainter and colder. Today, the CMBR fills the entire space with a temperature of about 2.7 Kelvin. This is the oldest possible temperature in the universe, and it is impossible to reach absolute zero, which is 0 Kelvin. However, the CMBR is not the only source of heat in space. There are also stars, planets, asteroids, comets, and other objects that emit radiation and heat up the surrounding space. The closer an object is to a star, the warmer it gets, and vice versa. For example, the surface temperature of Mercury, the closest planet to the Sun, can reach up to 427 Celsius during the day and drop to minus 173 Celsius at night. On the other hand, the surface temperature of Pluto, the farthest dwarf planet from the Sun, can be as low as minus 240 Celsius. The temperature of space also depends on the density and composition of the particles and radiation in a given region. For example, the interstellar medium, the space between the stars, contains mostly hydrogen and helium atoms, dust, and cosmic rays. The temperature of the interstellar medium can vary from 10 Kelvin in the coldest and densest molecular clouds to 100 Kelvin in the warmer and less dense dynamic clouds to 10,000 Kelvin in the hottest and most ionized plasma regions. So the question is, what happens if you are exposed to space? If you are in space without a spacesuit or a spacecraft, you will face several dangers, such as lack of oxygen, pressure, and radiation. But what about the cold? How long would it take for you to freeze to death? The answer is not as simple as you might think. Unlike on Earth, where you lose heat mostly by conduction, which is the direct contact of your body with the air or water. In space, you lose heat mostly by radiation, which is the emission of energy from your body. Radiation is much slower process than conduction, so you will not freeze instantly in space. In fact, you will die of suffocation or decompression long before you notice the cold. However, this does not mean that the cold is harmless. Depending on where you are in space, you could still experience extreme temperature changes that could damage your body. For example, if you are facing the sun, you could get burned by the intense solar radiation, which could reach up to 120 Celsius. If you are in the shadow of a planet or a moon, you could get chilled by the lack of solar radiation, which could drop to minus 150 Celsius. These temperature swings could cause your body to expand or contract, resulting in tissue damage or frostbite. Moreover, the cold could affect the objects that you are carrying or wearing. For example, if you have a metal watch or a ring, it could shrink and squeeze your skin. If you have a plastic bottle or a bag, it could crack and shatter. If you have a battery or a circuit, it could lose power and malfunction. Therefore, it is important to have proper isolation, so insulation and protection for yourself and your equipment when you are in space. In all, space is not a single substance, but rather a vast emptiness filled with various particles and radiation. Therefore, it does not have a single temperature, but rather a range of temperatures depending on the location and the conditions. The coldest possible temperature in space is 2.7 Kelvin or minus 270 Celsius, which is determined by the cosmic microwave background radiation, the CMBR. However, there are also stars, planets, asteroids, comets, and other objects that emit radiation and heat up the surrounding space. The temperature of space also depends on the density and composition of particles and radiation in a given region. Exposure to space without a spacesuit or a spacecraft is deadly, not only because of the lack of oxygen, pressure, and radiation, but also because of extreme temperature changes. Depending on where are you in space, you could face temperature as high as 427 Celsius or as low as minus 240 Celsius. These temperature swings could cause damage to your body and your equipment. Therefore, it is important to have proper insulation and protection for yourself and your equipment when you are in space. So viewers, that's all for today. I hope you find this video interesting and informative. If you have any question or comments, please let me know. And subscribe our channel for more this kind of content. I'll see you in my next video. Till that, take care, love you, goodbye.